Uh, Good morning, everyone. Can you please take a seat because we are supposed to start 2 minutes ago? Hello, hello. OK, people are sitting down. We have one request for you today. So we're going to run a scientific experiment. We realized yesterday it's quite noisy if people are talking in the back. So what we want to try out today is if people go upstairs and to the far back, if it's going to be much better or not. And to facilitate this experiment, we have removed the chairs in the back here. So please, if you have a break today and you want to just chat with someone, go upstairs to the very far back and try. And if it's more quiet, then we'll keep it. And if not, we'll do something else this afternoon. And with that, I mean, please try to pack in as much as you can because we want to have everyone seated. And we have like lots of empty holes here. And I will hand it off to Johan, who will try to introduce Colin because I can't pronounce his last name. So here we go.
Hi, and welcome, everyone. Hope you had a great last day. Today we're going to be doing the second keynote of the conference. And I'm really, really happy to be able to introduce Colin Brisbois, who is a close friend and coworker for the last 15 years, back and forth in different ways. 10 years ago also, we were both at EA, and we created this new organization together with an amazing group of artists and researchers and engineers. We really wanted to explore what the future of interactive entertainment would be, and that exploration is still going on. And I'm super happy to have Colin share a bit about sort of their journey that they've had over the last 10 years. So welcome, Colin.
I got that. Hey, good morning, everyone. Thanks for making it early. I know this is 9 a.m. game dev time. You know, it's a bit early, but thanks for making it. I'm happy to be here. So my name is Colin Brisbois, or Colin for short. And this talk is about 10 years of Seed. I can't believe it's been 10 years already. And the goal of this presentation is to give you a glimpse, I guess, into how we do R&D at EA outside of games and how it all ties back into the games. And I hope to share some lessons we've learned along the way, some stuff that worked, some stuff that didn't. And I hope you will find this useful. So let's get started. So like Jan said, we've been working on and off together for, I guess, 15 years now. But if you don't know me, so I started at, here's a quick overview of my path. So I started at EA Montreal back in 2004, where I worked on a bunch of games that you can see there. Started in the PS2, GameCube, Xbox era. And then after that, I spent a bit of time at DICE. This is where I met Johan and Christina and a few of the folks there, where I worked on Battlefield and Frostbite. At the time, it was a really cozy, small team, I would say. I think Frostbite was around like 40 people. I don't know how big Frostbite is these days, but it's much bigger than 40 people, as you can imagine, supporting all of these games at EA. And after that, a colleague of mine mentioned they were starting a Warner Brothers studio in Montreal. And I'm from Montreal. I wanted to go back to Montreal, and so I joined there as lead rendering engineer. And we worked on the Batman Arkham series, really amazing games. And then after that, I returned to EA, and that's when joined Seed with Johan, where I had a bunch of roles over the past 10 years. So I started as a rendering engineer, also held the role of head of tech, so overseeing the overall tech direction of the team. And now I actually run the team. In case people are wondering, I don't code anymore, and I do miss that. So maybe I should find some side project to, work on the weekends. And you can see the titles I worked on, some as like a direct developer, but also one as central tech. And I think that's the interesting piece about central tech is you can really have impact on a lot of variety of titles. I also have a blog. I don't update that very much these days, but there's a bunch of publications you can find there. So I've done a bunch of work across, AAA, engine, central tech, publications, stuff like that. Now, this talk is not about me, it's about Seed. So For those of you who don't know, SEED is a pioneering group at Electronic Arts, and we combine creativity with applied research. And the mission of the group is to explore, build, and help define the future of interactive entertainment. So what does that mean in practice, right? Really bold words. And so I'm going to try to break it down for you. So by explore, it means we take on risky R&D challenges that some of the game teams or some of those that have revenue-bearing obligations can't, or the space for. By build, the key word here is applied. So everything that we do, we aim to have our work in the games, appear in the games in some shape or form. Not always in the way that originally started, but we always try to find a way for things to make it into a game in some shape or form, with some technology artifacts delivered along the way. And, oops, sorry about that. And by define, because we look at longer-term timelines, we have the ability to drive some high-impact, differentiating long-term rewards, long-term investments that drive differentiation in the long term. And so ultimately, the vision here is, and this is inspired by that 1983 ad that we see farther, which is seeing further than the current approaches, right? And are there some fundamental technology improvements that we can do that will really change and power next generation games? And that's the vision for the group. So to do this, we have two key drivers that determine what we work on. So first, like I said, applied innovation. So we solve real problems at the intersection of game dev and academia. And our work has showed up in some of the games you can see to the right. I'm not going to cover all the games that our work has showed up in, but you're going to see some of that in the upcoming slides. And then the second one is something we call 10x thinking, like moonshots as well, where you really want to go, you want to look for exponential differentiation, disruptive solutions, right, rather than these incremental improvements. And so we have a team, and let me tell you a bit more about this great team. So we are a cross-disciplinary team with experts in domains that you can see here, like game AI, content creation, rendering, physics, animation, characters, worlds, a myriad of folks. We are distributed across the world, so around 50 people. We have presence in strong key EA locations. Some of the strong presence in key EA locations, so Stockholm, Montreal, Vancouver, and Redwood City, with some people sprinkled along the way from West Coast to East Coast in North America and in Europe as well. And finally, we are an engineering/researcher-led organization from top to bottom with technologists across the stack. And we think that's really important to have domains led by domain experts and sprinkled with a little project management, because you need some of that, and equal opportunity ideation. And by that, I mean anyone can come up with project ideas. It doesn't just come from the top, or just from the bottom as well. The charter of the team includes 3 key areas of contribution. So obviously, research and innovation, right? So driving future applied research in 4 key areas. So content creation, rendering and physics, game AI, and future experiences. Then the next part of the charter is incubation and adoption. So, I said our work ends up in the games and the engines and the pipelines and the tools. And for that, we partner closely with product teams across EA to help deliver these technology artifacts of our work. So like game teams, engine, tools, pipelines, everybody basically. And finally, partnerships and dissemination. So part of our group's charter is to contribute across the ecosystem. And we do that internally and externally. We do this with industrial partnerships. We have many partners here in the room. You know who you are. We also do quite a bit of partnerships with academia. We have 18 universities in the world that we partner with. We do the usual papers, patents, publications, stuff like that. So that's part of the charter of seed. And so if we were to look at our projects and how we try to map this over time, let me show you what that means. So if you think about strategic fit on one axis and you think about time on another axis, you could say that projects could be bucketed in multiple horizons. The first horizon of work is what we call evolutions. This is typically where standard game dev lives in. I put 0 to 24 months, but don't get overly attached to the numbers there. It's more just to create some differentiation. So horizon 1, evolutions. Then you have horizon 2, which are opportunities, so 24 to 48 months. And this is where the majority of our 10x projects live. And then moonshots, the revolutions, the long-term projects, 4, 5, 6, 7, 10 years plus. These are the horizon 3 projects. And so if you think about horizon 1 projects, from a perspective of software development, game development, they make a lot of sense strategically at the early in time, right? It's like something you need to do that brings a lot of value. But over time, these Horizon 1 projects they might not be as relevant, or they become, common value that everybody uses, so it doesn't drive as much differentiation. These are typically low to medium risk projects. Then you have Horizon 2, mid-strategic fit. They really get really powerful in the Horizon 2 timeline, and then after that, they also start fading away, just like Horizon 1. It takes a bit more time. These are medium to high-risk projects. And then finally, Horizon 3, strategically, they might not make sense right now. You might look at this and be like, hey, should we be working on this? Does it make sense? But over time, they make a lot of sense when they're successful. And these are the high-risk projects that we have in the portfolio. And so what's interesting and what I want to show you today is that we have some Horizon 2 and Horizon 3 projects, which is where the bulk of Seed's work is, that made it into EA's biggest games, which, basically now. So I'll cover this in just a bit. But first, I want to talk about cultivating innovation, and at least how we do it at Seed. So this is something that works for us, in the context of EA and who we are. It doesn't mean this is a recipe that you can just apply everywhere, but it does work for us, and I'm happy to share it with you. So here's my super scientific checklist. I'll get over each item. I'll skip the first one because we covered that already. So defining an R&D engine, right? So building this engine that will give you long-term disruption with a constant influx of new challenges. And, we're in a game company, we have to deliver value. So if we think of an R&D engine as this box, it has inputs and outputs that have to go through these razors. And, these razors, you can define what those razors are. For us, it's like 10x, moonshots, things like that. And then different remit filters, so like being clear about which horizon you operate in, and different research vectors, which I'll cover in just a bit. Basically, the razors act as this noise filter across all the inputs that you get. And the inputs, well, they can be sourced from anywhere. So we source internally from game teams, conversations we have with them, but also from our own experience. We have people on the team with many years of game development, and they also have great ideas. So we try to mishmash that and run that through the razors. And so all these challenges come in through the razors, and over time, as they go through the R&D engine, we'll generate some outputs in either Horizon 2 or Horizon 3. And so basically, you end up with this engine that has, a constant influx of new things to tackle and things that constantly come out, right? So you have this nice virtuous cycle. And there's always something coming out of the engine, which is really cool. And one point here, and I guess I kind of talked about this on the previous slide, is that today's Horizon 2 challenges, Horizon 3 as well, they become tomorrow's Horizon 1, right? Time moves forward. Now, if we take the R&D engine, the blue box that I had here, and we look inside that box, we can basically break it down into two main activities. So if you split horizontally, you'll say at the top you have high innovation. So keywords that come into your head are like revolutionary, forerunning, 10x, 100x, that sort of stuff. And then you have applications, so like games, engines, pipelines, tools, stuff like that. So, R&D, right? Research and prototypes for R and applications and tools for D. The outputs of these are interesting, right? So research output is generally dissemination. So things like papers, patents, publications, and communications through academic or industry partnerships. And then productization, well, it leads to things like proof of concepts, demos, technology artifacts, pilots with game teams or central tech, stuff like that. What's also interesting is that dissemination leads and informs productization, right? Some outputs of that work really drives, like R drives D, basically. And if we were to map it, across a spectrum, you could say, you go from risky and theoretical down to applied and proven, and that sweet spot in the middle is where it gets interesting. It's the incubative aspect of things. And it's a self-sustaining engine, right? So more research drives more productization, which is really cool. I'm just going to give you a quick overview of the process. So our process is centered around 3 key phases. So we have experiments, right? So this is where we explore the unknown to uncover potential breakthroughs. This is a time-boxed phase, right, where it results in things like proof of concepts, demos, tech reports, which is another artifact of the work that we do. Then there are the next phase, which is pilots. So this is when a concept shows promise. We partner with a product team, so like a game team, for example, and we create this joint agreement that defines scope, delivery, sign-off, the whole thing there. And together, we build prototypes in the game, in the engine, in the pipeline, sort of stuff. And then finally, handoff happens when a prototype or a piece of that work lands in production, and ownership has to transfer to the destination team. And so this is when we need to define, ongoing support. But once generally handed off, technology becomes theirs. We provide support every now and then, but we do define those parameters because we have more research to do. And what's interesting here is that as projects progress through the R&D workbench, from discovery to incubation to productization, we increase formality, right? You don't want to be overly formal with experiments. Obviously, you want to time box stuff. But it's when it starts showing up in product that you have to be a bit more formal about it. Obviously, having a research team or any team means hiring, the right people, good people. And I want to talk about how we look across our hires in, I guess, 2 different ways. So I-shaped people and T-shaped contributors. I don't know if you've heard that concept before. But basically, when you hire I-shaped people, these are folks that have strong mastery in a domain, right? They're domain experts, they're very specialized contributors, or they're early career, right? They've done a PhD in some very specific domain, very specific field, and they're really good at that. So these are folks who are, like I said, very specialized. And then what's interesting is that expertise is additive, not exclusive. And so if you hire people who are very specialized but have a growth mindset and the ability to expand beyond their current expertise, this is where you really get some really great innovators. Then there's the T-shaped people, which means someone who has deep expertise in one field but also the ability to stretch themselves, I guess, like the T-shape. These are typically, experienced professionals who also care about the broad context. And it's like, why does that matter? Why not just hire all these domain experts? Well, success in games depends on that blend of specialties and having these versatile collaborators. People who can work together and push boundaries and creativity. And so you need that to really drive differentiation. Now, once you have the people, you can build a culture of innovation. And if you think about it, innovative cultures are, I don't know what you have in mind here, but when I talk to people about this, people think, it's described as this like tolerance for failure, open to exploration, it's highly collaborative, it's not hierarchical, and there's a lot of belief that this leads to better results, better innovative performance. But there's this really great Harvard Business Review article to the right here. If you haven't read it, I highly recommend it. It talks about that there are these easy traits to like, what I mentioned at the beginning, but it's not all of it. And to sustain innovation, and that's what we're trying to do, right? For 10 years, we had to sustain it. You kind of have to balance that with maybe some less glamorous, maybe tougher things to cover here. So I would say some of the interesting ones, like rigorous discipline, right? So having clear frameworks, time boxing, like I mentioned, progress reporting to keep projects on track. That's super important. Nobody goes rogue. Can't just say, I'm going to work on this for 6 months, see you later. That usually doesn't work. Having brutal candor, being honest, respectful feedback among peers, but I think being able to have the conversations when something works or something doesn't. People get stuck in their ideas and they have to, sometimes get pulled out of it. But having that openness, I think, is really important. Then there's having high level of individual accountability, right? Ideas are endless. It's at the end of the day, it's execution that matters. And so yeah, being accountable is super important. And finally, I would say strong leadership. So, I talked about being led from top to bottom with technical folks, but we have domain experts that review the different R&D roadmaps, and we have a leadership council, that reviews and prioritizes the work. So there is still some amount of leadership in the chaos that is R&D. And in short, I would say innovation does thrive when you manage this sort of tension, right? And without it, I think the best intentions fail. So check out the article if you're interested in reading more about that. It's really cool. Now, creating room for innovation, there's a few principles that have helped us along the way to navigate the desire to drive innovation, but also being relevant to the business. So I would say, and it's going to be like it's a pretty text-heavy slide, so please bear with me. But there's a few of these things I wanted to make sure they were all together. So I would say balancing, right? So consulting experts, but also trusting your experience. I think that's super important. Listening. So production teams have great ideas. There are game teams who work on cyclic games. Every year they come out. Some people, their games take longer time. And across the game teams, production teams, people have great ideas. Stay a while and listen. Next, space. So creating room for the flying car versus the faster horse, super important when you drive innovation. Communicate, sharing your work and your roadmaps. Proven ideas need planning for productization. Here's another one, manage. And by manage, I mean expectations. Under-promise and over-deliver, not the other way around. Be clear about readiness and timelines, super important. Next one, protect. It's totally okay to not share all your ideas. Some early ideas need time to be proven before they lead to, or they need to be shared more broadly in some cool demos. So it's totally fine to protect ideas. Next is action. So capturing, documenting, applying lessons. Failures often lead to perpendicular successes, so it's really good to capture all of that. Filter, I talked about the R&D engine and those razors. Time is finite, right? So staying aligned with your vision, your mission, and your strategic focus. People would come at you with all these ideas. Well, there's a bunch of those that don't make sense for your group, and that's totally okay. And you need to have those conversations, but you need to filter that. And finally, collaborating. innovation happens everywhere. I think there's great value to partner with people across the company and even outside the company and bringing them on that journey with you. Now, when it comes to delivery, right, so delivering value, different people will inevitably ask what value means to you. And I think there's different ways to define that. So first, developer-facing, right? So tools, technologies, systems that really empower the game devs, right? The creators. There's obviously more room for failure here, but it still needs to be robust because it gets used in production. Then there's the player-facing outputs, right? So tech that enhances gameplay, experiences, this has to be reliable, this has to be robust because it affects players, a paying customer. Then there's internal knowledge, right? So building expertise through collaborations and documentation. The impact might not appear right away, but it will appear, it will prove invaluable over time. And then finally, external influence, so sharing, right, through talks like we do at conferences, papers, open source, partnerships. I think it drives industry progress and mutual learning, and I guess this is why all of you come to these conferences. And ultimately, when it comes to internal delivery, it requires alignment. And end-to-end success will inevitably depend on strong partnerships across R&D, across game, across tools, engines, service teams as well, with clear agreements, shared expectations, and collaboration throughout the delivery. In general, I would say throwing things over the fence just doesn't work, so you really have to do all of this together. So there are some general thoughts I didn't really know how to frame in this slide deck, so I just put them on the same slide. So, and I think they're really important to. There are things that we found to have sustaining success. So anchoring projects into real clear goals, right? So tying every exploration to a real measurable outcome. This reveals like trade-off versus value, and you can also look at perpendicular opportunities. Then there's organizing around problem spaces, not features, right? So our R&D at C is structured around research vectors. What that means is people can work and have full ownership, have more parallel progress and depth in the work that they do. Then document everything, right? Capturing not just the results, but the process, super important. And compare improvements to original approaches to gauge real gains. Iterate fast, then harden. Make it robust later. Learn quickly, prove what works, whatever is required, then make it robust, which is a great way to not over-engineering at the beginning. I talked about value. Establishing several lenses to capture value. Different audiences value different things, right? So some value visual quality, some people value time saved, money saved, iteration speed, Defining tangible impact and different lenses to look at your work really helps tell that story to different audiences in the company. And then finally, demos. I think I don't have to convince you about that, but always be ready to show your work and have a pipeline that enables you to refresh these demos, right? So prototypes, videos, presentation, whatever the artifact is. But keeping those fresh and visible is super important. Now, I'm going to dive, I talked about the process, the framework, the mindset. I want to jump into some concrete work that we did. So this first one is around digital humans. So back in 2017, we had the idea to build a new head acquisition pipeline centered around a light stage. So if you think about it, back in 2017, this was a Horizon 3 moonshot where we wanted to rethink quality and what quality should look like and blur the lines between film and game visuals and capture that likeness at unprecedented levels. And so this started as a close partnership with the University of Southern California, ICT's group with Paul Debevec. And several years down the line, This enabled some of the highest quality character visuals in games. In Battlefield 6, for example, this was a really close partnership with Battlefield Studios, with Frostbite, the tools and tech team, and Seed. And I think you can see it from screenshots from the game here. And if you haven't picked up the game yet, you should. It's really amazing. As someone who's worked on Battlefield before, I'm really happy to see Battlefield and how it turned out, and I'm playing it every day, actually. It's incredible. You should pick it up. And there's also a talk about this, so don't miss it. But that's the end state. So if we go back in time and we look at the journey, so this is us assembling the light stage, which is a pretty cool photo from the team. So it was initially assembled, and then we had to move it to a different facility because EA was reconfiguring all of its capture facilities. But then COVID happened, right? And so in-person hardware work when there's a pandemic doesn't really work well. So, then time flew, pandemic went away, and then productization started back in 2024. Well, before that, but it was fully productized by 2024. And what that means is a custom-built cloud pipeline for processing and scalability. It's also custom-built computer vision for 3D and 4D processing. And since 2017, hardware changed and had to be upgraded, so we had to upgrade things like cameras, lenses, polarizers, lights, cabling, a lot of stuff. Also, we had to get it UL inspected because our legal team wanted to ensure that talent doesn't get electrocuted inside the device, which is, super important when you look at this sort of hardware. I don't think people could have been electrocuted, but it's all good. We're UL inspected. And again, this is a really close partnership between different teams, right? So USCICT, the EA Capture team, the Tools and Tech team, the character teams across EA, especially recently with the Battlefield team. Now, this work has led to some really great learnings, especially when it comes to turning R&D hardware into product, which is something we've never done before. And so productizing experimental hardware involves things you might not be expecting. Like I talked about UL inspection and safety certifications. This is not typical in software. So that's one we learned. It also demands close collaborations with teams who are going to operate it, right? So training people to operate it. And again, tight teamwork between artists, engineers, researchers, and the capture crew. We had a bunch of challenges along the way, solving capture inconsistencies across different subjects, distributed hardware, software across time zones. Can you please reboot that computer, because you're not in that studio, and the computer's in Los Angeles, and we're in Montreal, for example. And training actors to perform inside a dome of light, which is quite different than a head-mounted camera. But ultimately, this became a major Horizon 3 success story that's widely used across EA for digital human scanning needs, which really shows that long-term R&D can deliver real differentiating impact today. Here's another case study, so voice-to-face. So if you haven't heard about voice-to-face, voice-to-face is what we created to drive facial animation from speech. So it basically transforms voice input into an expressive facial motion. So it works offline and real-time. The real-time version we just showed at SIGGRAPH 2025. And the offline version we've used internally for content creation. So it was used in Battlefield cinematics and in FC for crowd chanting. And so it shows that it works across genres. And what we've done is we've fully integrated this inside of EA's ecosystem of tools, and it's a solution ultimately that accelerates both cinematic and narrative workflows while keeping full artistic control, which is super important. Now, the journey of voice-to-face is kind of a fascinating one. It was Seed's first major big machine learning project. And And early experiments showed promise, but the quality initially fell short of game team expectations. Now, the breakthrough here happened when we deeply invested in data, which is an essential step for machine learning projects, which maybe at the time was not as clear for us, but now it definitely is. And and then productization came around 2020, so we partnered with the FC team to deploy, like I said, the model for crowd chanting. Then it was centralized through the tools and tech team, which means they could support game teams using that service, while at the same time we work, they support version 1.0, and we continue the work on advancing the research. And one really key thing that we've developed here is a rig-agnostic method which allows seamless deployment across different games, because different games have different facial rigs, and that really enabled us to scale it and make it a company-wide offering. So this work led to some really great learnings. So I have 4 of those for you. Prioritizing data quality, right? So machine learning models are only as strong as their training data. Deep investment in high-quality data sets has really led to some major gains across performance and realism. Next one is engaging artists early, right? So for tech that intersects the creative workflows, I think early involvement from artists and animators here, like bringing them on that journey, ensures usability, adoption, and success. Communicating openly, right? Transparency about what the tech can do and what it can't. It really builds trust, and it sets clear expectations. I think, initially the technique was not working so well with emotional performance, but through these, communicating with artists and hearing their feedback, I think it really helped guide the team, for the R&D aspect. And finally, like I said, co-developing with artists, I think continuous collaboration surfaced through these critical insights. So for example, like the impact of having accurate tongue animation, which initially the model did not support, really helped shape the roadmap and improve realism. So that was really key as part of co-development. Here's another one, real-time GI. So I think I don't have to say to many of you that, real-time GI has been a multi-decade challenge and a dream for many. And for us, really, it started, from a GDC demo that you might have seen, and then many years of work across Seed and Frostbite and the studios. There's some really great presentations in the middle here. You should check them out if you haven't seen them. And then recently shipping in college football and in skate. Now, real-time GI for us really amplifies and simplifies workflows and enables real-time editing, which is really the powerful aspect of it all, rather than the dynamicness of it, at least for these projects. So with our friends at Frostbite and with the college football team, this is one of the technologies, as part of a series of technologies that enabled the team to ship 150 stadiums properly lit that look great, which before they were not able to do. So, enabling iteration at scale. The journey for this project is also very interesting. Like I said, it started with a GDC 2018 demo that we created specifically to prove out the DirectX ray tracing API with Microsoft and the upcoming ray tracing hardware, at least at that time. And then it took a bit of time, and then it got productized with our close partnership with Frostbite. Like I said, it led to shipping 150 stadiums in NCAA college football, but also enabling dynamic open world and UGC in skate. And so in the end, close partnership between Seed, Frostbite, college football, and skate team. And in the end, we successfully shipped cutting-edge ray tracing from demo to production. So here are some learnings from this project. I have 4 of those. So especially around productizing rendering tech demos. So this is the key thing here. So validating with the real world conditions. So high internal confidence, I think, is not enough. It's only when it's when the real world scenarios show up that the true edge cases, performance bottlenecks, and integration challenges, appear. Next, productization takes time. Transforming advanced rendering tech into something that's stable, shippable, robust. It requires patience, iteration, and close collaboration between research and production team. Next one is a really important one when you work with others, is having these champions on both sides. So having a strong partner on the destination team, I think, is really critical for adoption and alignment. They really help bridge the gap between the R&D intent and the production reality. And then finally, securing buy-in across the stack, right? So this technology is going to affect many people on the team. So, work with artists to understand and support their work, the workflow changes. Engineers, right? Engineers care about performance and the integration costs. So having to work with them here is really key. And obviously producers, right? So people care about schedule, having a fallback, a plan B, right? So having a plan B is always great. And here's my the last case I have for you today, which is around game AI. So recently, we've used reinforcement learning to train and improve goalkeeper positioning in FC26. And so let me show you a quick trailer on this specific improvement.
Our second big gameplay innovation for FC26 applies to both competitive and authentic gameplay. A focus on refining what we call the gameplay fundamentals. Goalkeeping, agility, tackles and interceptions, passing and dribbling, attacking movement, and physicality. Here's what we've heard over the last year and how we rework those fundamentals to address your feedback. Goalkeepers are inconsistent. Expect keepers to be smarter and more consistent in FC26. We're using machine learning to train them in hundreds of thousands of in-game situations to find the best positioning, including those little micro steps world-class keepers use to close the angle.
Right, so you can read the paper. There's a link there. I realize I should have put a QR code, but when we post the slides, you'll have the link. You can also search the paper by name. And also, please check out this great piece, this gameplay deep dive that the FC team put together on the EA website, which really covers improvements made across the game, including the goalie AI. So the journey for this one, the story began back in 2017 when Seed set out to explore how reinforcement learning could shape future of gameplay. So we partnered really closely with DICE. You can see the video at the top right. This is on YouTube, by the way, where we experiment with early reinforcement learning bots in Battlefield 1. So this was a bold prototype that we showed at GDC 2018. It never shipped. But it really showcased some early real-time reinforcement learning in a AAA game. And so that was a glimpse into what was possible when machine learning and large-scale player-facing systems interact together. And so over the following years, the technologies matured, and so did we, and so the capabilities, led to some of the work that you saw, that I presented, that I showed before on FC. You think a first-person shooter has nothing to do with a football or soccer game, but there's a lot of artifacts that came from that work. And so by 2023, this is where the work style transition. So we partnered really closely with the FC team. Mike Jones here, I was talking about champions. Mike Jones is our champion on the FC team. And, we deployed real-time inference for goalkeeper positioning in FC26. And for us, really, what this proved is that ML-driven control could meet the strict performance, reliability, and design expectations of a global AAA title. I don't think there's anything bigger than a global AAA title like FC. Next. Yes, so some learnings, right? I have 5 of those for you. So especially on reinforcement learning in games. So productization is a journey, right? Turning experimental machine learning research into something that's production ready. It takes time, it takes iteration, and persistence. The next one is respecting the craft. So gameplay AI is at the heart of the player experience, right? So earning the game team's trust means proving that machine learning-driven systems are reliable, controllable, and ultimately make the game better. So really important here. Robustness, right? Machine learning introduces new kinds of uncertainty if you compare that to the previous ways of programming everything. And getting it into production means validating, stabilizing, hardening until it meets those gameplay expectations and KPIs. Finally, another one, champions, well, they drive adoption. I talk about Mike Jones. Having a strong partner makes all the difference because they align the product goals and ensure that what we actually build ships. And then finally, collaboration. It's everything. This only worked for us because when it was time to implement it into the game, our researchers worked closely with the FC gameplay team. They were working side by side in the game engine, in the game's code base every day. So I want to wrap up here. It's been 10 years. We're running fast toward the future, and we're just getting started. R&D is hard, but as we probably saw when it works, the payoff is extraordinary. And turning research into production takes the right mix of people, so engineers, artists, researchers, producers, leaders, everyone align around a shared goal of innovation. Building sustainable R&D engine takes time and balance, right? So forward-looking exploration, calculated risk-taking, continuous delivery of value. And I think we found that balance through persistence, iteration, and collaboration, and tremendous support from teams across EA. And in the end, really, I think it's all about the people, the ideas, creating that space for innovation, and how you tell that story. I hope this inspires you into your own R&D journey, and maybe you can leverage some of these ideas, and I'm happy to hear your thoughts on our process. And with that, happy anniversary, Seed. It's been 10 years, established November 5th, 2015. And if you want to know more, you can check it out, seed.ea.com, and you will find all of our papers and presentations there. And with that, thank you very much.